So I've opened this HP counter up again because I'm not terribly happy with the crystal oven in it. It's having done calibration on it, it's drifting within 24 hours by about 0.2 Hertz, which isn't a lot, but I'm a bit of a perfectionist, and even my Marconi counter doesn't drift that much, so that must have a better oven in it. But of course this is the lowest cost option oven, medium stability oven. So having done a bit of research on the internet, there's a guy and his website's called Circuit Valley, who's constructed his own oven board, and he's got hold of various ovens, and one of them was an MV89A. Can't remember who makes it, but that's according to his measurements or figures or whatever he's got from the company that make it. That is even better than the ultra stability oven option from HP. So I've got the data on it, on that MV89A, and it's exactly the same size as this one, but, and it's a big but, it's not 4-pin compatible. The oven in at the moment in this one needs 5 volts, and the one on eBay is the MV89 is 12 volts. That's not a problem because there's 12 volts on the board here, but it won't fit in the pins will not fit into this board. So the other thing is, it's on its adjustment pin, the new one I'm planning to put in needs 0 to 5 from the DAC, 0 to 5 volts from the DAC. Well, I've done the calibration routine again. I've measured what's coming out of the DAC. Where's the DAC? That's the DAC, and I believe that's the input to the trimming control on the oven. I measured on there, and it's 0 to 5, which is exactly what the MV89 uses. So my plan is to order one of these MV89As from China, of course, surplus ones, and it'll take weeks to come because all the Chinese are having a holiday at the moment, but that's not a problem. It can be a long-term project to do this. And then I think what I'll do is I'll make a little circuit board and mount it above here, because as I said, the pins are not compatible with the ones on this board, and just wire it in like that. So that's about it for now. I'm going to put this thing back together and wait for the MV89A double crystal oven to come. So it's about 10 or 12 days now since I last did the calibration on the HP counter, and as you can see, it's drifted by nearly 0.2 Hertz, which is fairly poor really. As I said a few minutes ago, my Recordano counter, I think I calibrated that about a year ago, and that's drifted by about 0.06 Hertz, I think. So it's obviously got a better oven oscillator than this HP's got, but you know, as I said, it's got the medium stability oven in it. But anyway, I went ahead and ordered an MV89A, which is what you can see in front of you here, and got it from China, of course, and it was used, as they all are, and it arrived this morning. It took about 12 days to come, which is pretty good. I'm used to waiting for weeks and weeks for stuff to come from China. I think the quickest I've ever had, I think, is 5 days. But anyway, so this it was strange on the eBay listing for this. I could choose various years, and they varied in price. I think 2016 ones were 3 times as much as a 2004 model, so I chose a 2004 model, and that was fairly cheap for what it was. But I can't quite see why the newer ones should be more expensive, but maybe they've improved the design. Anyway, the older ones would, in theory, have better stability, having more chance to age. So I've got it wired up anyway on the bench, and it's been on for a few hours. And have a look at what it's drawing at the moment. It's drawing 398, just less than 400 milliamps anyway. When I first connected it up, it was drawing from cold about 1.3, 1.4 amps, which is quite a lot really, but I think my main worry is, will the counter's power supply handle that if when I install it? But I'll worry about that later. So I've had it on for a few hours, as I said, and I'll just show you how I've got it connected up. So that's the basic connection diagram. You've got plus 12, 0 volts, a 5 volt reference inside it, which should be temperature compensated obviously, and you've got a trim connection and the output. And what I've done is I've wired a 10k pot between earth and plus 5 reference, and taken the tap off to the trim connection, and this is what I've got. That's the 1010 pot obviously, and outputs on this, outputs on the yellow wire, 12 volts on there, and I'll put the scope on and you can have a look and see what it looks like. It's quite a nice sine wave coming out of it. So that's the output on the scope, nice sine wave, and 2.12 volts peak to peak, which is reasonable. That should be fine. So I think I'll next go for trimming it. So at the moment I roughly trimmed it in about an hour ago, and as you can see it's 9.999999.905, so it's a bit less than 1.1 Hertz error at the moment, and it's been fairly stable after an hour's warm up. So what I think I will do now is, because I think the main factor in this is in this test is the pot. You know, that's going to be temperature sensitive, and although this is pretty warm, I can put my fingers on it, but it's pretty hot, and this pot's going to be affected by temperature. So what I think I might do is wrap it up in some foam and then trim it in, and leave it for a few days and just see how stable it is. So I'm just going to get some foam and wrap it up. So I've just tie wrapped a piece of foam around it, and you can just about see the adjustment pot in there. You've got to be careful when you're adjusting it though. It's got to be in a fairly stable position, because gravity affects these. If you turn it round through 90 degrees, or change the axis of gravity by 90 degrees, it will affect the frequency. But I'm just going to try and trim it in now. See if I can get the counter on. Okay, I've got the Ready to trim it now. Wrong way. So we're reading down to a resolution of 100 megahertz here, so it's pretty critical. It's very fine adjustment. Right, that's going to be good enough, I think. It's really hard to get it exactly right. No, it's almost impossible, but I'm going to leave it there. I mean, that's only it's only off by 500 microhertz now, and I wonder what the voltage is on the adjustment pin. So yeah, I'm getting 2.55 roughly volts on the adjustment pin, which is well within the range of the DAC, because that would normally be connected to the DAC in the HP counter. So yeah, so I'm going to leave it there for now, and that's going to be part one, I think, of this video. I'm just going to keep monitoring it, keep running it for a few days and see how much drift I get, and hopefully there won't be much at all. And then next part of the video we'll be trying to install it in the HP counter, and that should be fun because it is fairly big, but I don't think it's any bigger than the one that's in there now. And I'll have to make a little circuit board for it to sit on, and I'll mount that on the board that's in there. So I think I'll upload this now and then do another one in a few days' time. Bye for now.